Our speaker tonight, Jon Gertner, is a book author and a contributing writer for the New York Times and has written for the Washington Post, the Wall Street Journal, and others. And I, for one, am really looking forward to this because, as I said to him in my email, this is an interesting combination of history and science. And talking about Greenland, it's kind of ironic that we're talking about Greenland with spring approaching, but it's an interesting look at history, at science, at climate change, at things that went on back. And by the way, Mr. Gertner, I just want to tell our audience that, by the way, tomorrow is the 1-year anniversary of our last in-person talk. So, so this you now complete a 365-day cycle of virtual talks. So, would you welcome our guest tonight, Jon Gertner?
Well, thank you, everybody. Thanks for coming. Can you hear? Is that sound okay, Mark? Is that coming through okay?
Sounds good.
Good, 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 good. Well, I wish I could be there. I wish it's always more of a pleasure to all be in person together. And it's actually really nice for me to talk to a Cape Cod audience. I'm coming to you from New Jersey. I'm actually in my son's room. He's in college, but we've been going to Cape Cod for 20 years to Wellfleet. And in fact, this book actually started in Cape Cod in a way. One of the great scientists in the book, a guy named Chet Langway, who was a glaciologist who studied ice cores. He drilled into the ice of Greenland, lived in Harwich. And when I began the book, Chet was one of the first people I went to visit, and I went to spend a day with him and talk about his times in the 50s and 1960s, especially in Greenland. So Cape Cod is very meaningful for me. So I'd like tonight to talk a little bit, I'd like to give you just a little bit of background on Greenland. I realize not many people have been there. I ended up going there 6 times, I think, for the book, and spending quite a lot of time up in the Arctic. But Greenland isn't necessarily well understood by a lot of us, so I'll give a little bit of background. I'd like to talk a little bit about some of the themes in the book, and then I think I'd like, if it's okay, to just talk about sort of what I was trying to do with the book. You know, what as a writer kind of challenged me and made this book, I guess, interesting, or how I conceptualized the storytelling in it. So with all that said, I'm going to actually show a few photos as we go along. And Mark was good enough to sort of walk me through this. And it should work out okay, I think. We're good. Can you guys, if anyone wants to nod their head, that seems to be okay? Yeah? Okay, oh good, I see a thumbs up, great. So Greenland is just, let me just get up to, okay, I can't quite, there we go, okay. So just a couple quick facts on Greenland as just some background. Greenland's the largest island in the world if we don't count Australia, which is more frequently considered a continent. It covers an area about 3 times the size of Texas, or about 5 times the size of California. Obviously, you don't want to get Greenland mixed up with Iceland, which is actually further away from Cape Cod, from the United States. And temperature-wise and climate-wise, compared to Greenland, Iceland is kind of balmy and tropical. Greenland is a pretty formidable climate. Most of the island is above the Arctic Circle. Greenland is actually the least densely populated country in the world if we don't actually include Antarctica, which isn't a country, it's more of a territory, which exists by arrangement of treaties between countries. Although the population of Greenland varies from census to census, usually it hovers around 56,000 people. And most of those residents of Greenland really live in that narrow strip of land on the southwestern coast of Greenland. There are some very kind of rugged villages on the east coast as well. And although there are cities in Greenland, I don't think by our own standards we would necessarily call them cities by American standards. The largest city in Greenland is a town called Nuuk, which is the capital, N-U-U-K, and it has 16,000 people. And it has 1 traffic light that's blinking. But again, these are intimate towns, and some of the tourist towns, the very beautiful towns by the glaciers, which you may have heard of, like Ilulissat and Sissamut, are even smaller with 5,000 to 6,000 residents. About 88% of the residents in Greenland are of Inuit descent, and the rest are Danes and Europeans. And we know that the current residents Inuit came over from northern Canada, from a kind of frozen straits connecting Greenland to Ellesmere Island in Canada, probably between 800 and 900 years ago. And one thing I realized pretty quickly as I began my research for this book is that Inuit survived in Greenland not in spite of the ice, but because of the ice. They created an entire culture around hunting and gathering and really sort of arranging their lives around these sort of long summer seasons, frigid, dark winter seasons, hunting and gathering, in a place really where agriculture was often impossible. Since the early 1700s, really Denmark has made the largest impact on Greenland. They sent missionaries here and later colonized the island for economic development. And since the 1970s, Greenland has been earning more and more independence from Denmark, but Denmark still subsidizes its gross domestic product. And the main source of income here for Greenlanders is really fishing, and that's from shrimp, halibut, seal, and tourism, and some mining, which has become more and more important in Greenland. Copper, nickel, gold, rubies, but especially these rare earth metals that are starting to be developed, especially in the southern part of the island, and especially as this ice sheet, this massive ice sheet, which I'll talk about in a second, starts to recede and starts to reveal some land that can be used for mineral development. So, you know, there's this question, okay, so why should we care about Greenland? Why does it matter? Why did Jon Gertner write an entire book about it and spend 5 years of his life going back and forth to Greenland? Those are very good questions. Greenland matters in a very sort of just forthright economic sense in some ways because of its minerals, like I talked about, and what some people speculate is newly accessible oil as the Arctic Ocean, this floating ice cover to the north of Greenland, starts to melt and makes oil more accessible, or drilling for oil more accessible. There's also this notion that it's a strategic importance, that as the Arctic Ocean becomes less and less clogged with ice, it becomes a sort of passageway for ships to go on shortcuts between the continents. That's a very big deal, and it makes Greenland really valuable enough that, as we know, even Donald Trump was very interested in buying it a couple of years ago when he actually sort of bandied that about. So there are all these sort of other reasons, but mainly for me, and what interested me for writing my book, is the ice. The ice covers about 80% of Greenland, and you can see it on that map on the right side. You might think of Greenland as a kind of enormous cupcake where the frosting doesn't quite go to the edges. And the ice sheet is not flat, it's a large dome of ice. And in the center, it's about 10,000 feet high, and that means it's about 2 miles thick from the top of the ice sheet to the bedrock below. And the ice here, if you've ever flown over Greenland, say going to Scandinavia, it's kind of beyond comprehension. At its widest part, it's about 700 miles across, and it's more than 1,000 miles long, and it's just hundreds and hundreds of miles of really nothing but featureless ice. And the Greenland ice sheet, as we call it, or some people abbreviate it with GRIS or Greece, is only one of 2 remaining ice sheets left in the world. The other is in Antarctica. And these are a link to the former world. They're a link to the ice ages and the ice sheets that have receded everywhere else in Northern Europe and in Northeast United States. Keep in mind, if we went back in time about 15,000 years, if we were all sitting in Cape Cod or Boston, 15,000 years ago, we would be very uncomfortable because we would actually be under about like a mile of ice. And this was the Laurentide ice sheet that covered large swaths of North America. And what happened in that case is that ice sheet about 12,000, 11,000 years ago, as the Earth began to warm, it shattered and it melted and it broke and it slid into the sea, raising sea levels dramatically. And oceanographers and geologists have a name for that kind of moment. They call it a meltwater pulse, when enormous amounts of ice fall from land into the sea and raise sea levels. And there are classifications. There's meltwater pulse 1A, meltwater pulse 1B. But what we know is that these meltwater pulses, as these glaciers that used to cover the Northeast and used to cover Northern Europe fell into the sea, they raised sea levels sometimes just a foot in a century, but sometimes perhaps as much as 6 or 7 or 8 or 9 feet in a century, which is a rather dramatic sea level rise, almost incomprehensible. And I think that, in a sense, is why an ice sheet really matters in a warming world. It's simple. It holds a lot of water, and that water can fall into the ocean as the temperatures rise, as air temperatures rise, but also as ocean temperatures rise and warm the edges and sort of infiltrate the edges of the ice sheet as well. And the reason these ice sheets hold so much water is that they really exist over the course, they're the product of hundreds of thousands, or in some cases in Antarctica, millions of years of snowfalls. Snowfalls that have fallen, not melted, compacted as more snow has kind of compiled and piled upon it over and over again. And it has built up into these layers that are, as I said, at least in the middle of Greenland, go to about 2 miles thick. Now, if all the ice in Greenland suddenly broke apart and melted and fell into the ocean, we would be talking about a sea level rise of 24 feet. And New York City and most of the world's coastal cities would be drowned. And that doesn't include any of the ice from West Antarctica in particular, that's also quite unstable. There's a glacier, for instance, in West Antarctica called Thwaites Glacier that appears to be very unstable at the moment and is in jeopardy of kind of beginning to collapse, as they call it. And that alone could add 2 or 3 or 4 feet of sea level rise this century to the oceans. Now, these massive sea level rises are not going to happen next year. They're not going to happen by 2050. They may not even happen by 2100. Certainly Greenland, some of the projections that even in a very warm world, some of the ice in Greenland might last hundreds and hundreds of years, which would certainly be a good thing. But here's the other thing that's extremely problematic about ice sheets is that they are lagging indicators. They take a while to respond to what we call forcings, like a warmer world, warmer air, warmer oceans, but they always do respond. And in the end, it may be the case that the response is pretty much unstoppable. Now, for about the last 20 years, Greenland's mass of ice is declining, and that means it loses more ice every summer than it gains back in snowfall in the winter. And it loses these from glaciers that break off huge icebergs at the edges of that ice sheet, as well as these kind of melting events. And you've probably seen pictures of sled dogs running in these kind of blue lakes of meltwater that characterize, I think, these warm temperatures that are more and more sort of besetting the ice sheet and creating these large sort of losses of ice every summer. Right now, Greenland loses about 300 billion tons of ice every year. And that's about 1 millimeter, which isn't that much. But unfortunately, here's the really bad thing. We know that the losses seem to be accelerating. And really the great question is, will Greenland hit a point of no return? Or maybe has Greenland hit a point of no return already, after which the melting can't be stopped? So about 8 or 9 years ago, all of this drew my attention. It was 2012, I think, when Greenland underwent one of these really hot summers and these sort of massive meltdown. And for a moment, just for a moment, it was on the front pages of some newspapers. And it had drawn my attention. I thought, wow, Greenland is melting and breaking and collapsing. And as a journalist, I thought, well, this is really an amazing story. And of course, I could see, apart from sort of excited to go to Greenland to sort of understand the story, I could see that the terrible downsides here were just all over, that there would be floods, property losses, and especially an impact on the world's poorest that live closest to water. And really, if we wanted to sort of crystallize the problem, it was that we built a civilization by the water in many cases on the mistaken assumption that climates and sea levels remain stable, when in fact they don't, and they never have. And there's an entire field of what we call paleoclimatology that has told us that throughout history, temperatures and sea levels have gone up and down. But I began to wonder, okay, well, how fast will Greenland's ice sheet change? How fast will this happen? How fast does an ice sheet collapse? Do we have enough time to save our cities? Is that really something that we'll see in our lifetime? Um, and so I began this story looking at Greenland's ice sheet, wondering about its past and present and future. And in many ways, this book began as a kind of climate change book about how one seemingly irrelevant part of the world would soon affect us all. But I think as I began to read a little more deeply, I also thought of it as a book that could focus on human discovery of the natural world, that it hopefully could be both. And I thought of the book as framed around three main questions and three main mysteries, I guess we could say, that were or are being solved by human actors at the moment. And there's this first question. It's a historical question. It's about sort of the early days. It's that, how did we kind of come to understand the Greenland ice sheet? Who were the people who did that work? Because back in the 1700s and 1800s, in that era before air travel, when even as the age of ballooning began, you couldn't really go up in the air and sort of look over the Greenland ice sheet. So it was a great mystery as to how far it went and what even was in the middle. And there was a small number of people, intrepid explorers, who sort of began to sort of understand and work their way courageously over the ice sheet to try and understand that place. The second question to me was, what secrets did the ice sheet contain? What we know is that by the second part of the 20th century, as a lot of the ice sheet was mapped and understood, sort of that age of exploration became more of an age of science. Scientists began digging into the ice sheet and finding that it was a kind of almanac of time, that it recorded past events. Now, you could find traces through sort of chemical and physical analysis of the ice. You could find traces of ash from Krakatoa, for instance, or you could find some sort of the atomic residue from Hiroshima. You could even find traces of leaded gasoline from that era of leaded gasoline. When more sophisticated tests came online as well, you could look at isotopes in the ice and try and understand past temperatures. So these questions, these secrets, sort of made up this sort of second mystery of understanding what the ice sheet could reveal or how it could be significant to science. The third question was a little harder. It was for me, okay, well, how will this ice sheet fall apart? What can we predict? What will be the impacts? And who are the people who are working on those questions? So as you could see, going into this project, which felt a bit daunting, this idea of telling the past, present, and future of the ice sheet, I could see that I wasn't going to tell the story of the Inuit, which is a really interesting story. There are great books on the Inuit. The Inuit actually avoided the ice sheet. It was not a place of sustenance or a place for any kind of living. There was no hunting or fishing to be done there. It was thought that evil spirits and folklore traditions of the Inuit dwelled there. It was something to be avoided. So for me, it became very much a story more of Europeans and Americans who, for the most part, came to Greenland to try and explore and understand and sort of predict the behavior of this ice sheet. Now, the next question is, okay, so where does this story of Greenland's ice sheet begin? I had mentioned that the Inuit came to Greenland about 800 to 900 years ago from Canada. At about the same time the Inuit came to Greenland, there was a small colony of people from Iceland and from Scandinavia who were living in the southwestern area of Greenland. These are known as the Greenland Norse. And they lived in two settlements called the Eastern Settlement and the Western Settlement. They had been led there by a warrior from Iceland named Eric the Red. He was actually the father of Leif Erikson. And the Greenland Norse lived there from about 985 to 1425. But the Greenland Norse died out, and we're not really sure why they died out. This is still a mystery. It's hotly debated amongst scientists, anthropologists, sort of trying to understand the causes. Was there some kind of skirmish between the Norse and the Inuit? Was there some kind of famine event brought on by disease? Was there a kind of storm that wiped out all the sailors and hunters of the Norse? We don't really know. There's even some theories that maybe the Norse sort of began to emigrate back to Iceland and to Denmark. But because they died out and disappeared, at least for me, and we're not sure why, historically, they were a dead end. So for me, I really decided to begin with somebody named Friedrich Nansen. And Nansen was a Norwegian scientist. He later became famous as an explorer and a humanitarian. He actually later won the Nobel Prize years after his exploration days for helping World War I refugees. But in 1888, as a very young man, Friedrich Nansen decided he was going to take a team of men up to Greenland. He was Norwegian, he was going to ski across the Greenland ice cap. And he was going to be the first person in the world who had ever crossed the Greenland ice cap. And as you can tell from the photo, Friedrich Nansen was pretty serious about what he would do. At the time, no one really knew what was in the middle of the Greenland ice sheet. There were theories, and there were some speculations that maybe there was an oasis with meadows and reindeer in the middle of the ice sheet. But again, nobody knew. It was prior to that age of aviation, and there was no airborne observation. It was even an era before anybody had come to the North Pole, and nobody had even come close to Antarctica. So Greenland was a kind of terra nova. Nansen's idea and what they did with he and his men were they took a sealing ship, a ship that hunts seals, and they asked to be dropped off on the eastern edge of Greenland, which you can see in that white map there. And they got off the ship, took a rowboat through a kind of very hellish journey to the coast of Greenland. And what they were going to do was pull their sleds up the eastern slope of the ice sheet, and then they were going to ski down or ski across the top of the ice sheet and then ski down the western half. And they were going to take a ship home from the western coast. The planned route was actually going to be longer than 280 miles, but what happened was it ended up being about 280 miles. They all lived, but this was an absolutely miserable journey. And in fact, when they got dropped off, they had to kind of to get onto the ice sheet. You go through a zone that's very perilous, full of crevasses and sort of these deadly holes in the ice. And if I could just read a very short passage of what it was like for these guys, carrying this stuff in the frigid cold over these crevasses, and might give you a little bit of flavor for this. 6 men were dragging 5 heavy sledges. Each of the sleds were laden with at least 200 pounds of gear: tents, sleeping bags, raincoats, skis, snowshoes, cameras, thermometers, barometers, canned food, dried food, tea, sugar, coffee, chocolate, matches, stoves, and fuel. All the sleds pulled during the night when the August sun isn't melting the snow atop the ice sheet, transforming it into a soft white bog that makes hauling even more difficult. Their skis remained packed up for later. They would be useless at this steep gradient anyway. Using boots fitted with sharp metal crampons, the men need to hike up through the crevasse zone to make their way to what they anticipate to be the smooth rising dome of the central ice sheet. The ropes for the sledges burn into their shoulders. The white glare, even at nighttime, when the sun barely slips below the horizon, leaves them nearly snowblind. The frozen hills and valleys seem to ripple on without end. One of Nansen's team will later note that the terrain in these early days makes him feel hopeless, as if he is walking upon the waves of an interminable ocean of ice. Now, the fact that Nansen's group all survived and found, as they discovered, that the ice sheet didn't really have an oasis in the center where reindeer were frolicking. What it was a continuous kind of cover of ice, was something of a discovery. And Nansen, trained as a zoologist, actually made a good number of scientific observations and recordings. And in Europe and in Scandinavia, when Nansen and his team returned, he was hailed as a great hero, as a great scientist and adventurer. Now, I think this is interesting because really this is the beginning, I think, of the modern era for studying the Greenland ice sheet with Nansen. And it's, again, why I began the book with Nansen. But what I found is that, there's a kind of regular succession of explorers as we move along through time. And fortunately for me as an author, Nansen, like all good heroes, had a kind of deadly and evil rival. And this was Robert Peary. Robert Peary, who's sort of much more famous for purportedly reaching the North Pole. This is a claim that's actually sort of in dispute for those of you who read a lot about the Arctic. There's a question of whether Peary ever reached the North Pole. I think I've always found it most persuasive that he probably came close but didn't reach it. But what was also true is that in the early part of his exploration career, before Peary ever thought about the North Pole or got to the close to the North Pole, he spent most of his time in Greenland. And when Greenland was actually the sort of his great ambition, that he believed that he wanted to be the first person to cross the ice sheet. When his wife told him that Nansen had just crossed the ice sheet, she wrote that it was as if you had told Peary that somebody had just died. His dream was crushed. He could no longer be the first. So what do you do if you can't be the first to do this? Well, you do something bigger and better and even more dangerous. And what Peary decided was that a few years later, in 1891, again, Nansen had crossed the ice sheet in 1888. In 1891, Peary was going to cross the ice sheet, but he was going to cross it in the north. And not only was he going to go once across it, he was going to go there and back. It was a much longer, much more difficult trek. It was a slog of 1,200 miles to go across and back. And I won't go into the details here. I go into great details in the book, but I'll just say that he succeeds actually in doing this twice, 2 years apart, to go across the ice and back. And these are some of the most miserable expeditions in the Arctic that I've ever read about. That by the end, the men are really like eating shoe leather and eating frozen chunks of walrus meat and starting to eat their sled dogs. And it's just horrible, beyond horrible. In this desperate, really, attempt to get home and stave off hunger. But in a sense, I think the takeaway is that Nansen and Peary formed this duo. They don't really solve the mysteries of the ice sheet, but they begin to show us and the world what it is, that it's a place that human beings can cross and investigate. In fact, Peary starts bringing along scientists on his expeditions to map the coast and look at the flora and the fauna and the ice. And that they begin to sort of talk about how this place, this last great ice sheet, holds keys to how this former world, the world that was once covered in ice, looked and behaved. Peary and Nansen also inspire a kind of next generation of explorers. And really the greatest of them all in some ways was this fellow, Rasmussen. Rasmussen was part Inuit. He grew up partly in Greenland and partly in Denmark. He was younger than Peary and Nansen, but to him, they were his great hero. And in fact, in later life, they all became kind of correspondents with each other. Rasmussen, I think we can think of as the last of the great Greenland explorers, but also somebody who bridged this early age of heroic exploration, which I think is represented by people like Nansen and Peary, and also this sort of next generation of scientists who came later. What Rasmussen did was he was a fantastic dog sledder, and he would kind of go on these very long expeditions to chart different parts of Greenland as well as different parts of northern Canada. He became, I guess we could say, a de facto anthropologist, where he would collect stories and folklore from the Inuit. He also tried to solve the question of how this diaspora of Inuit and natives had sort of spread around northern Canada and Greenland by sort of tracking different stories that matched up in different areas of the world. He also, very importantly, did something unique in that he set up a trading station which comes in to play later in the northwest corner of Greenland. He called it Thule Station, spelled Thule. And at Thule Station, Rasmussen had come to the idea that these sort of more isolated tribes of Inuit would eventually become kind of, if not corrupted by modern life, that they would eventually have to enter the modern world. And he could trade them for their fox pelts, which had a price in Europe and were popular, and you could give them food to sustain them through some of these difficult winters, but he could also give them guns and knives and other things that they required. History is kind of messy, I think, is what I found out. As much as I wish there was a very kind of neat age of exploration and then neat age of science that followed right after, that isn't really the case. I mean, as I mentioned, Nansen was a scientist too. Rasmussen did anthropology and brought scientists along with him. And the person who followed in, I think, Rasmussen's footsteps was this fellow, Alfred Wegner, who was a German scientist. Wegner's name might ring a bell. He was the one who created the idea of continental drift, that all the continents were once packed together in a supercontinent called Pangaea. That idea has kind of been supplanted by something more modern called plate tectonics. But Wegner's early career, and really a lot of his life, was not about continental drift, but was about Greenland. And he was a meteorologist who was fascinated by the weather patterns that moved over the Arctic and into Europe. And he spent several expeditions, both covering Greenland's ice sheet on foot with ponies. And in his early part of life, in 1913, when he was a young man, he actually had a miserable crossing of the ice sheet himself on foot. In 1930, and the sunset of his career, Alfred Wegner decided that he was going to have one great last expedition in Greenland, one great scientific experiment, really, that he was going to take dozens of scientists up to Greenland, set up different weather stations in different parts of the island. But most importantly, he was going to create a mid-ice station right in the center of the ice sheet. It's called Eismitte, E-I-S-M-I-T-T-E. And the mid-ice station would have several scientists who would stay there through the entire winter. It was, as I said, at about 10,000 feet. That's where the center of the ice sheet, this was a little bit lower. And really the temperatures in the middle of the ice sheet during winter are just brutal. It got as low as minus 80 degrees. And there was no communication with any of the coast. These men who stayed the winter, there were 3 of them, were really cut off. I won't sort of go into what happens at mid-ice station. It's rather tragic and complicated, and it's really exciting if you want to read it in the book, and I can always write better than I can talk. But I think what's important is that out of this effort kind of came some of the beginnings of the solutions to, or that second mystery I talked about. Like, what is the mystery of the ice sheet? What's inside of it? What secrets does it hold? One of the scientists who was stationed for the winter at Eismitte, at the mid-ice station, was a guy named Ernst Sorge, who was a glaciologist. And his idea was that he was going to dig down into the ice sheet. Now, these men were living basically in a cave under the ice, in the middle of the ice sheet, with not a lot of fuel and not a lot of food. Sorge decided that he was going to dig a staircase into the ice sheet, and he went down 50 feet with a shovel. And he would cart up these perfectly sort of measured blocks and weigh them and try and check their density. What he discovered is that as you go down in the ice sheet, you can sort of see regular striations, regular stripes where different snowfalls have fallen over the years. And when I talked about that idea of the ice sheet as a kind of almanac of time, some people describe it as almost like tree rings, that if you dig down into the ice sheet, you can sort of see the layers of snow that represent every year or every winter. That was what Sorge was seeing. And he was also sort of finding out that you could actually see a regular pattern to the density of the ice, the stripes in the ice, so to speak, as he went further and further down. And in a sense, this was a kind of minor breakthrough. But I think it began this sort of modern study of the ice sheet and what we call ice cores. Ice cores are not a staircase dug out of ice and not blocks, but they're drilling rigs that pull up a core of ice from the ice sheet. But they follow that same idea that you can pull up pieces of the ice sheet and look at those sort of yearly rings, so to speak, to find sort of data or find information about the past, information about temperatures. In some places, especially in Antarctica, you can find tiny air bubbles trapped in ice that can tell you what the atmosphere was like thousands of years ago. This is what we also call paleoclimatology. But in short, what Sorga began, I think, was the study that the ice sheet is a record of weather and time and events. What happened after Wegner's expedition in 1930 was unfortunately not a lot. I'll just go through again just for a recap that after Nansen, there was Peary and Rasmussen and Wegner. There were other explorers kind of mixed in here, but these are the big ones. But what happened after Wegner was that World War II sort of interrupted. And nothing happened on the ice sheet for a good 10 or 15 years. And really, a lot of the research on the ice sheet didn't pick up until some French teams went back to the center of the ice in the early 1950s, led by a sort of intrepid scientist named Paul-Émile Victor. And they set up a camp actually in the center of the ice sheet, right near where Wegner had done it about 20 years before. And they did the similar kinds of experiments, digging into the ice. Even they began to drill into the ice. And that was sort of the beginning, I think, of post-war research. What really kicked things off even further was when the Americans came. In the late 1940s and early 1950s, as the Cold War began, an idea that took hold amongst US military strategists was that the quickest way from Moscow to Washington was over the Arctic and was through Greenland, and that the United States needed a kind of defense outpost somewhere up there that could deploy military planes, eventually the idea of nuclear weapons, that this would need to be situated somewhere in the far, far north. Where it actually was situated and where it was built very, very quickly was in Thule, and it became known as Thule Air Force Base. And it was actually on a site suggested many years before by Knud Rasmussen, who had built that and created that trading station, really in the same spot. Remember, Rasmussen's idea was you can trade furs and other things to the native Inuit. The Americans came and literally built a base for 10,000 people almost overnight in the course of 6 months. What was interesting for science is that this massive Cold War budget for building in the Arctic also allowed a lot of scientists to work for the military and work for the Army, especially in the Army Corps of Engineers. There were all sorts of questions about how do you land a plane on ice, or how do you wage a war or defensive tactics on an ice sheet. And so they hired a lot of glaciologists in an era when this science was very young. There were tremendous budgets for this kind of work. And there were also some crazy ideas. For instance, about 7 years after Thule Air Force Base was built, the Americans built about 130 miles east of that, something called Camp Century, which was a military base literally under the ice. They carved it out of the snow and they let it be covered over the course of many years, so that what they had was a subglacial military base. Eventually, unfortunately, they also used it for the idea of testing out the idea of maintaining a nuclear arsenal under the ice, project that was called Iceworm, that was actually came to be seen as completely impractical. But Camp Century held several hundred men who were stationed there, no women actually, for about 5 years, until the whole structure began to collapse from the weight of the snow. But before it did that, something really important happened in science. Some of those scientists who worked for the Army Corps of Engineers, and one in particular, a guy named Henry Botter, had this dream that he wanted to drill an ice core, or drill a hole literally from the surface of Greenland to the bedrock. Camp Century wasn't really in the center of the ice sheet. So the center of the ice sheet, it's 2 miles down. It was in a place where it was about a mile above the surface, or that was the expectation. And beginning in the early 1960s, some men they actually found a drilling rig that they bought in Oklahoma, and they brought it up, they airlifted it up to Greenland, and they began to drill a hole in the Greenland ice sheet. Now, when you're in Camp Century, when you're under the ice already, you just kind of drill through the floor. So they literally set it up, and it had a hollow drill bit with saw teeth around, and it would go down rotating. Right now, the science of drilling ice cores, or the engineering of drilling ice cores, is very systematized. And they drill down, they yank up a 1 meter ice core, as it's known. Back then, in these early days, this was a brand new kind of science and engineering technique. They brought up all sorts of cores of different sizes and different lengths, but they kept going down, down, down over the course of every year, until eventually on July 4th, 1966, they hit the bedrock at Camp Century, underneath Camp Century at about a mile down. And the scientist, as I mentioned, who did a lot of this ice core recording and monitoring was Chet, Chet Langway from Harwich, Massachusetts, who actually retired up there. What I think is important is that they had this ice from Camp Century, but they almost didn't know what to do with it. It took a lot of science, literally, and it took a lot of sort of experimentation to try and figure out what secrets this ice could tell. And some Danish scientists, someone named Billy Dansgaard, actually figured out how you could very efficiently figure out temperatures by going through samples of the ice. And through the scientists working on this ice core that came out of Camp Century. And again, when I say ice core, this is many pieces of cylinders that together would make up a mile, but they're many broken pieces of cylinders. And they began to sort of work on a paper that they published in 1969 in Science magazine called 1,000 Centuries of Climate from a Greenland Ice Core. And it might be one of the more important, certainly to me, one of the more interesting scientific papers of the 20th century. What it showed from this ice core was that what temperatures were like literally over the course of 100,000 years and how they changed by tracing it back through these isotopes in the ice that they were sampling. And they also found out that the ice core reveals something very strange, that sometimes, as in 12,000 years ago, back when everyone here in Cape Cod was still under about a mile of ice, that the climate didn't actually go up and down slowly, but that it can flip suddenly, almost like a light switch. And this is an idea that's called abrupt climate change, but suddenly, at least in the ice core record, it can get much warmer very fast. This ice core, as well as others in Greenland, and you can see some others. This is from GISP-2, which is called Greenland Ice Sheet Project 2, which was from the 1980s and early 1990s. They're actually housed in Lakewood, Colorado, in something called the National Ice Core Laboratory. Some of the old ice cores from Camp Century are here. Some are in Denmark, but almost all of the ones from Greenland done by American scientists are here, as well as some from Antarctica and other glaciers around the world. This is a room, if you ever get the chance to visit, the back storeroom is kept at -40 degrees. Pens don't work there, unfortunately, so you have to use a pencil, and cell phone batteries discharge immediately from the cold. But what they have is this library of ice cores. And when I visited, I was very interested in seeing this abrupt climate change from Greenland from 12,000 years ago. And a scientist actually brought this transitional ice core, as they describe it, out to a viewing table. Unfortunately, that photo right there is not that actual ice core. And you can sort of see the stripes within the ice marking every winter. On one side of the ice core, these stripes were very narrow. On the other, they were very wide. And the scientists said, you know, on one side of this ice core is the Ice Age, and on the other is the end of the Ice Age. And in this ice core represented about 10 years of time. And in that 10 years of time, the temperature went up about 10 degrees. And I thought it's quite a sobering idea, because this idea, I think we tend to accept that temperatures just go up gradually and slowly. We can see through the ice cores, again, some of these secrets of the ice have revealed that that doesn't always hold. That's not always the case, and that the climate can be more unpredictable than we think. So I think this takes us to the third great question of the ice sheet. And the first was, what is it? How do you explore it? The second is about unlocking its historical secrets. The third is, how will it collapse? If we now see Greenland, as I said, losing 300 billion tons of ice per year, how long can it last? Scientists like these fellows are monitoring glaciers. These are great rivers of ice that run off the edges of the ice sheet. They're spectacular. This is Helheim Glacier on the eastern coast of Greenland. The fellow in the dark hat is David Holland. I actually camped with him for a week on the western side of Greenland at a glacier called Jakobshavn. But Greenland loses ice two ways for the most part. It loses it through these icebergs that come off these glaciers, and it loses it through these meltwaters that form every summer from warmer temperatures and create great rivers and pools that eventually pour off the sides of the ice sheet. One problem, I think one of the more worrisome problems in looking ahead to the future of the Greenland ice sheet, is that warmer air and temperatures, especially during the summers, put the health of the ice sheet in jeopardy. They create a number of feedback loops. For instance, the more ice that the ice sheet loses, it gets lower in elevation. And as it gets lower in elevation, the temperatures are warmer. So it's subjected to even warmer temperatures, and it gets lower and lower. So in that sense, we can see that the more ice that the ice sheet loses, the more ice that the ice sheet loses. Another feedback loop is something that has to do with something called albedo, which is the darkening of the ice sheet. As temperatures become warmer in Greenland, different parts of the ice sheet get darker. They get darker because they lose snow cover. Snow is very bright compared to the ice underneath, but also because algae blooms are happening on the western side of the ice sheet, and also this covering of dust. And when there's this dark cover, it absorbs more sunlight and it hastens the melt. And it creates this, again, this kind of albedo feedback loop. So this sort of takeaway, which is not sort of happy to relate, is sort of that kind of idea: the more Greenland melts, the more it melts. And unless really, I think we come to terms with sort of keeping temperature changes, these sort of climate patterns in check, we really run the risk of reaching those points of no return. I often get asked, well, can we save the Greenland ice sheet? And I say, well, I think most of the science says that we could save a good portion of it, maybe even most of it, if we act really quickly and really decisively. But at the rate we're going, I mean, it seems very difficult to stop this pattern unless we do something drastic in terms of arresting the temperature changes, and for sure keeping temperature changes, as many of you might be familiar with the Paris Agreement, under 2 degrees centigrade. If we could keep it to 1.5 degrees centigrade this century, it would certainly make a huge difference in the health of this ice sheet, and really in sea level rises all over the world and for all of us. I hope that gives you a bit of a flavor for what I wrote about. I just going to stop the share there, but again, I'm happy to take some questions. I think there's a couple questions in the chat. Mark, should I just jump in and answer some of those, or?
Well, that's what you got me here for. So.
Oh, okay.
I'm your wingman. Never fair.
Oh.
I got a couple of questions. We know that Greenland got its name. You mentioned about Eric the Red Leaf Erikson. They were like the original real estate agents, because they were trying to get people to come. What is the actual population of Greenland today?
Oh, okay. It's about 56,000. And again, almost all of that is in the villages and towns on the western edge of on the western coast, southwestern coast in particular.
Is there any ecological ramifications to taking an ice core? I mean, is it anything harmful to that?
No, there is not. I mean, there's no danger of it injuring the ice sheet or keep creating a crack in the ice sheet. In fact, what some of the ice cores realized pretty early was that you had to actually fill up the hole you were making after you pulled the drill out. For instance, if you wanted to pause, because the ice sheet would just seal back up. In fact, you would kind of put liquid into the hole, like an antifreeze almost, so that the hole would stay open. But there's nothing really. I mean, there are microbes, but you're not talking about any sort of danger. And really, these ice, I think the biggest ecological impact might be some kind of pollution from, scientific teams working in these pristine environments. But that might have been the case in the 50s and 60s, especially with Camp Century. I mean, Camp Century actually, as you know from the book, they literally brought like a nuclear generator, and there's low-level nuclear waste kind of sealed under this northwestern part of the Greenland ice sheet. But increasingly since the 70s, I mean, scientific teams have been incredibly careful about kind of keeping clean, keeping house, and using materials that are not polluting. I mean, there are trucks and cars and some snowmobiles, but for the most part, you're talking about a very low impact environment, and everything that they bring up there is carted back out.
If you've got a question, type it into the chat feature. One of the things that you wrote in your book, and I found it fascinating, and it kind of gives people a sense of just how bitterly cold it is. And I'm glad you showed all those things with Peary and the other explorers. You mentioned about just some of the things that they had to undergo. For example, that their breath would freeze and crystallize inside of their sleeping bags.
Yeah.
Even though they're basically surrounded by water because it's frozen, so they can't really get to it. So they were thirsty on the way out, they're thirsty on the way in. It's just some of the actual hardships that they faced are almost mind-boggling. I mean, can you explain a couple of those?
Sure. I mean, I think reading about one thing that was really just incredibly enjoyable for me doing the research of the book. I don't know if enjoyable is the right word, but certainly transporting, was to read these first-person accounts by these men, and for the most part, it was almost all men, not exclusively, but for the most part, of what they experienced as they were sort of doing these crossings. And there is this question about like why they exposed themselves to such abject misery. And really, almost all of those early expeditions ended with sort of near starvation, and sometimes there was death. And it wasn't just the cold, it was the wind, it was the rain, it was sometimes just one miserable day after another. I'm not sure I've ever kind of come to a clear understanding, even after reading what must be hundreds of accounts of explorers, sort of what drove them. It was certainly a different day and age. I guess I might leave it for the readers to sort of read, but those details I think are just astounding, of how much unpleasantness people will put themselves through to maybe find new knowledge, or to be the first to achieve something, to gain some sort of measure of fame or notoriety for doing it.
Yeah. I was wondering if it's one of those Sir Edmund Hillary because it's their moment.
Well, there's some of that for sure. I think absolutely. Like, I'm not, and of course, because it's there doesn't really answer the question, does it? We just don't know.
We've got a couple questions here. Can we do anything to reverse the ice melting, such as being carbon neutral?
Mm-hmm. Yeah, for sure we can slow it down. You know, there are some really insightful scientific papers I've read that look at different scenarios for warming, where if we've arrested the sort of, you know, if we've gotten, say, to become what we call net zero in carbon emissions by 2050, you know, what kind of temperature changes would then ensue and what would be the effect on the ice sheets. It's model it. I'm sorry, I'm going to go through a little bit of a complicated answer, but modeling an ice sheet, modeling the future of an ice sheet is more complicated than modeling the future of what temperatures might become. There's all sorts of complicated sort of factors that we're not really sure we understand. However, it's pretty clear that the lower we keep temperatures, the more ice will endure by far. And in fact, if we keep temperatures to 1.5 degrees centigrade, you know, for sure most of the ice sheet will endure for 1,000 years. I think the dire scenario is if we let temperatures go up more than 2.7 degrees, we lose the ice sheet. This doesn't happen overnight. It happens over the case of 700 or 800 years. So yeah, we can save vast areas of our icy Arctic areas by keeping temperatures in check, addressing climate change. The sooner is better. It's urgent. I think that idea that certain things are set in motion, that certain areas of the ice sheet are going to be subject to loss, that a certain amount of ice melt is already baked in because of the CO2 that's in the atmosphere, is something we can't get around. There's another question of, like, you know, are there these what are called geoengineering solutions? You know, can we create cloud covers, or can we kind of somehow shelter the ice from the sun or other things? And those are really speculative at this point. I mean, I would never say that those would work. We just don't know. But what seems pretty certain is the faster we address climate change, the more we preserve the ice sheets. And I think the last point I'd say is that, you know, I am guilty of it too. I rolled out this notion that if all the ice in Greenland were to melt, it would raise sea levels 24 feet. But that's not going to happen anytime in the near future. On the other hand, you know, 1 foot or 2 feet or 3 feet of sea level rise can be catastrophic, especially with a storm surge, and especially in a low-lying area. I mean, I think of Cape Cod, I think of Wellfleet, or I think of the you know, the highway out to Provincetown. You know, those areas are incredibly vulnerable, and there's so many coastal areas like that around the United States and really around the world. So, so I don't think we have to worry about 24 feet, but we can worry a lot about 3 feet, and that's real, and that's dangerous, and that's serious.
You mentioned the way the ice melts. Does sublimation also contribute to ice loss?
Sublimation would be, I think, just going directly from ice to atmosphere. No, not significantly. For most of the ice loss, it's melt pouring off the. That would be I think, if I'm understanding it correctly, sublimation would be a direct phase change from ice to atmosphere, and it wouldn't go through the melting. But the really big losses are these calving glaciers from these big glaciers that I pointed to, like Helheim or Jakobshavn, or these melt events. You know, last summer when Greenland melted, or excuse me, 2 summers ago, you know, it can lose 10 billion tons of water in a day, or even more. It can lose 20 billion tons of water in a couple of days. So those are catastrophic events, and if the ice sheet undergoes, you know, those continually every summer, it gets very hard for it to build back up.
Are there differences between the cores from the north versus the cores from the south portions of the country?
Yeah, every core is different, and that's a really interesting question. The reason why, and I go into this a bit in the book, the reason why scientists, the American scientists and European scientists in the early 1990s wanted to pull a core from the center of Greenland's ice sheet is that the ice sheet moves. It kind of flows. I mean, the classic example is that it's like pancake batter. As the snow pours down on top, it sort of spreads out, and that spread at the edges crashes off as icebergs from the very edges in the glaciers. But in the center of the ice sheet, you don't get that flow or those folds in the ice that are created as glaciers or as the ice sheet sort of rolls over and spreads. So there are differences, in short, from the north to the south. The best ice for scientific purposes were the sort of most orderly levels, the most orderly sort of rings of the tree are from the center of the ice sheet. And that would be what we know of as GISP, which stands for Greenland Ice Sheet Project, from the early 1990s, that pulled up a really pristine core that was 2 miles long.
I was glad you had that slide of Robert Peary, because in your book you make mention of how poorly he and how woefully he treated the Inuit Indians, and that he just kept treating them as lower life forms. I mean, could you expound on that? And how many Inuit are left in Greenland?
Yeah, it's a complicated question. I think I'm going to say about 40 to 45,000 of the 56,000 residents would be Inuit. I should have that figure. I apologize if I don't. There are, marriages between Danes and those of Inuit descent there too. So that's one part of the question. Peary really, I think, the word I think of when I think of Peary is that he was exploitative. I mean, I guess you could say he treated the Inuit poorly. He thought of it as sort of like somebody who was there to kind of socialize and show them, his greatness, I suppose. The irony is that he actually adopted Inuit methods for travel, that he saw that the only way you could kind of cross the ice sheet in this kind of pre-mechanical world, again, before they had sort of automated trailers to kind of cross it or vehicles to do that, or before they had airplanes, was if you used dog teams and if you used furs and you adopted the methods of the Inuit, people who had really been covering, sledding over glaciers for hundreds and hundreds of years. So he took what he could from their culture, and at the same time didn't treat them particularly well at all. And yeah, I do go into the details of that in the book. And he actually fathered a child with an Inuit woman as well.
Well, I want to thank you for tying in history, science, climate change, really doing a fascinating job of explaining the ramifications of it, and how long did it take you to ultimately study? I think you said about 6-7 years, but how long were you on this? And in a way, it doesn't sound like you're done with this one. Is it still a work in progress for you?
No. I think I'll move on to the next book, and I have this other job as a journalist writing. But I think I do write about climate change, not exclusively, but it keeps my head in it. So, and of course, with things like Twitter, you can always be apprised of the latest scientific paper about Greenland, which is great. So I can kind of keep up on the science as long as I have the time to follow that. But I said this in the book too. It's not. Well, I have a glaciologist friend who says, the thing about these glaciers and these ice sheets is you can say the sky is falling, and it really is falling, but it just hasn't happened yet. Even as Greenland and Antarctica are losing, hundreds of millions of tons of ice per year, hundreds of billions, excuse me. I think what we're seeing is really just the beginning of what's going to happen in the next 10 or 20 or 30 years. So those numbers will increase. And as much as I sort of, my book might indicate that there's a kind of catastrophic nature to the precariousness of the ice sheets, it's really just begun. And this is a problem that I think we'll be talking a lot more about in 5 years and in 10 years. So these are, unfortunately, really just early days for this kind of, I think, transition to a wetter world, a warmer world, but also a world of higher sea levels.
Well, thank you for taking the time to join us tonight. This has been great. Again, it's kind of ironic that as spring is looming, we're talking about temperatures 80 below, but winter never seems to end, does it? So
No.
The book is called The Ice at the Edge of the World. Thank you very much for joining us. His name is Jon Gertner. It's available at Eight Cousins Bookseller. Thank you, everyone, for joining us. Stay safe. Thank you, Mr. Gertner. Good luck. And thanks for taking the time.
Oh, it was a pleasure. Thank you all very much for coming. Thank you, Mark. It was great. I hope you enjoyed it, and I hope you enjoy the book.
All right. Thank you, everybody. Stay safe.
Great. Take care, Mark.